Thanks very much for joining us today. I'm very excited to welcome our guest speakers from InSTEDD. We have Ed Jezierski, who's the Vice President of Engineering, and also Eric Rasmussen. And InSTEDD, I'm sure many of you are familiar, but they are a Bay Area-based nonprofit that focuses on using technology in emergency situations, like, for example, natural disasters or disease outbreaks. And Google has had a very long relationship with InSTEDD that we're very proud of. Going back to as far as 2006. So we were actually their first funder when they were a very new startup in Palo Alto, and we actually continue to support their work, particularly in Southeast Asia, where they're working on disease surveillance and management, and they have an innovation lab in Cambodia. But today, Ed's going to focus on their work in Haiti right after the earthquake. They were one of the very first organizations on the ground, and they actually worked directly with search and rescue efforts to identify survivors under the rubble and actually free those survivors. So a very exciting effort. We're very proud of it, and we're very excited to hear a little more today about the work that they did there. So welcome to InSTEDD.
Thank you. Good morning, good afternoon. It's a pleasure to be here. Thank you for the opportunity to talk. My name is Eric Rasmussen. I'm the CEO for InSTEDD. InSTEDD, as Joanne mentioned, has a very long tradition with Google. We were the first organization that I know of that Google spun off. We are an independent 501c3. We work on two particular things. One, we work on humanitarian-based, free and open source software that we have used in a number of very difficult places, and it's for information flow when it really, really matters that information move. The other thing we do is technical capacity building. We have the ability to teach in the developing world with the people actually using our software, and we give them the opportunity to make that software their own. We opened our website in January of 2008. So what we're looking at here is about 2.5 years of effort, and just about 2 years to the week after we opened our website, Haiti happened. And that's what we're going to talk about today, what it means to have an agile technology ethos when lives are at stake. On the 12th of January, 2010, infrastructure in Haiti effectively disappeared. Things that used to be difficult, even in the best of times, became all but impossible. I have had 18 or so deployments. I worked in Katrina, I worked in Banda Aceh, I've worked in 4 different wars. This was the worst I've ever seen. The numbers are a little soft, nobody actually knows, but it's something on the order of 250,000 dead, and about 1 million homeless, and about 250,000 destroyed buildings. Absolutely astonishing level of damage. The United Nations was there within about 48 hours, and they are in charge of most aspects of disaster response on the international stage. We showed up very shortly afterwards, and as a consequence, what we have here is the first humanitarian forum, 2 o'clock on that Saturday, I believe, afternoon. The earthquake had been on a Tuesday. One of the things to note here is that nobody in the room speaks Creole. That's important. We went from that humanitarian forum meeting back over to the Port-au-Prince airfield where we were working with the United Nations Search and Rescue Dispatch Center. We first found our colleagues on the Icelandic Search and Rescue team, and then went right next door to the adjacent tent to the UN Search and Rescue Dispatch Center, where you see in the brown hat Nico Ditada, who is an engineer with InSTEDD, working with Map Action, an implementing partner for the Office of Coordinator for Humanitarian Assistance for the UN, and they are working on trying to get information around the field to dispatch search and rescue teams just like this. There were a lot of search and rescue teams that were on the ground by the time we got there. This is 4 days after the earthquake, and we have something on the order of 50 teams. It was 56 at the end of the search and rescue phase. You can see under USA, 9 teams are there. That is roughly 1/3 of the entire U.S. contingent of urban search and rescue teams. It is very difficult to move around Port-au-Prince in the best of times. When the streets are blocked and there never were any street signs, you wind up having to give coordinates. It turns out that coordinates are not always latitude and longitude. MGRS is another version, and there are many, many more beyond that. coordination of information on where things were located was a big part of our collective problem. You also note the +88. That +88 means that people are using satellite phones to communicate, because until we got well into the first week, there were no cell signals working efficiently in Port-au-Prince. There was some scratchy stuff, but not much. The people who were picking up folks out of the rubble were taking them to where they could, and those 3 hospitals I just showed were a part of it. This was the Manusta Hospital. That is excellent lighting, as you can tell, within that surgical suite, because it's sunshine. We were doing this in the open air. We did more than 50 amputations in the street, because there was no heavy equipment in Haiti, and it was necessary to simply remove limbs for people who were trapped. And it looked like this. And unfortunately, as I mentioned, nobody spoke Creole. And these people speak only Creole, so we have a bit of a problem in communication. Health information systems were English messages written on bandages. The people who were uninjured still had no homes to go back to, so they went where they could and established what they could for living conditions. This, as you can tell, is in a bit of a depression. That depression was 6 weeks before the onset of the rainy season. You can imagine what this looks like, and you can see some of the floods that washed away some of these camps on YouTube. Critical infrastructure includes water pumps. And part of what we saw here is the normal delivery of water, which is in these water sachets. This is ordinary for Haiti, but ordinarily those sachets are 2 cents apiece. By the time we got there, they were 10 cents apiece, which meant dehydration and hygiene were already beginning to suffer. We found that there were people still trapped in the rubble, alive, when we got there, and people like this man walking to work, trying to get the country back together again, that's a working hypothesis, would hear people screaming, hear people moaning under the rubble, and had no way to contact central authorities and needed to have a method to do that. We also found this, that radio stations were coming back up, but radios require either the delivery of electrical outlets for power, or delivery of batteries, and they were few, or running off a car, which required fuel, and that was in very short supply. However, cell phone charging systems off the batteries that you see there, car batteries, were a common industry, so we knew that we'd be able to reach people by cell phone. We went out to find out just how the search and rescue teams were doing business, what they required in the course of their day. We attended the same briefings that they did, and then we got to work. This is Nico Detada working on the Port-au-Prince airfield, and he did not sleep for most of 3 days, working with people all over the world. And an important aspect of our lifeline is the red circle that you see over there. That is a BGAN satellite terminal. We'll talk more about that in just a minute. And we also tuned in very quickly to the cell system in Haiti itself, and you can see that Nico is beginning to exchange data in ways that were working for the systems that we knew were live in Port-au-Prince. We began to get friends with this man, Hamish Pritchard, formerly of the UK's British Antarctic Survey Team, and he was carrying messages to us, and I'm going to let Ed Jezierski, our VP of Engineering, take over from there. Ed?
Thank you, Eric. And as I transition, I wanted to talk a little bit about what was the end result of our work in Haiti. We ended up deploying a system that allowed survivors with cell phones to actually text in their location or whatever help they needed in whatever form. That would then get routed to Crowdflower, who was providing crowdsourced translation and geolocation, back into Thomson Reuters teams who were doing a journalistic system for Haitians, so they could get targeted messages saying this hospital opened, this clinic opened, HIV medicines are available here, or life-saving or at least life-improving information that they need to help themselves, like journalism for the survivors, and then off the RSS feeds, etc., to use Haiti as part of this project for 636 that you might have read about, and I'll talk about it in a second. But at the end of the day, 25,000 people were helped. Over 1 million text messages were sent out in order to help them with information. And I want to tell you a little bit about what, as an organization, we do to prepare for that. What is the sort of work that happens before that? And more importantly, what are other works that we're doing? Because InSTEDD's disaster response effort is really under 20% of what we do. And as a Google.org grantee, we think it's important for you to hear, understand, and engage in a way that might be interesting to you and helpful to the needs of the field. So as Eric said, what we do is we help create, deploy, and maintain technology that helps in humanitarian situations. This includes public health in villages in Southeast Asia, as well as more extreme crises like Haiti, with things in between, like supporting different organizations during the H1N1 crisis, helping hospitals hook up information to report syndromic for ILI surveillance. And with the way we work is really having very small teams. We're a very small group that goes out to the field, learns the requirements, implements them, does a lot of design in situ to see what's really the problem that needs solving, and evolves the technologies constantly to help with the problems that we face. And Google.org came to us 2 years and a half ago, with a challenge. They said, you know, if you choose to accept this challenge, we want you to deploy technologies that will help national and international disease surveillance in 6 countries in Southeast Asia, that in a way that spans from village reporting all the way to international policymakers and ministries of health exchanging information. Now, we were lucky because we were working in the support of a group that was doing the international exchange of information. Think about China, Vietnam, Laos, Cambodia deciding to share their disease numbers. These are numbers that could change tourism figures. It's national security to some extent. But then going all the way down to the field and helping with mobile phones and whatever technology would work, the reporting of these diseases. And to give you an idea of the magnitude of this challenge, imagine there's an organization in Cambodia right now where 10 people meet in a room and they tell them, we will ask you to go and help disease surveillance in the whole of the USA. You don't speak English, you don't read English. We want you to transform the way real-time disease surveillance gets done in the USA. Now go. And these Cambodians get on a plane and come to the USA, right? Of course, with some contacts, etc. So I want to tell you a little bit about the techniques that we did to design these technologies. So as Eric mentioned, we got created in TED as a TED Prize in 2006 by Larry Brilliant. Immediately after that, actually in 2007, we formed the current team, and we immediately started through a phase of rapid prototyping, trying on things, seeing what technologies were out there that would help both in crisis situations, as well as doing things in 2 weeks, trying them out in the field. This picture over here is from the first prototype of a tool called GeoChat that was actually tried out in Palo Alto search and rescue exercise operations 2 years ago. A lot of interaction design experiments. We did things that tapped into Facebook data to see if that could help monitor for diseases or get disaster teams together. We started working with the people in the country, seeing what data was available, what sort of infrastructure they had, what data they considered important and was up to date. You discover lots of things. For example, poultry density maps, chickens per square mile, is a very important map in Southeast Asia with all the H5N1 and avian flu risks that they have. So you start learning these things and how they get integrated into processes. What are the technologies they use? What is the organizations and the politics behind them? And what are the local innovators that are really working with the skills and resources they have to improve the system? So with all of this, working with local universities, we coalesced our first team there and started working. And our team now is all made out of Cambodian folks and locals who are getting training as part of the exercise. And we found many issues. The first issue is, in disease surveillance, collaboration gaps is the problem. Sometimes somebody has the right information about a disease outbreak happening, and it doesn't go to the right person. Or people that work in animal health and human health, and humans are a type of animal, so somehow they should be interrelated, don't work together. Different monitoring systems, different alerting systems, and we had to bridge those gaps. Also gaps in literacy and connectivity, obviously. There was very little appropriate design. A lot of efforts come from outside. They drop ship with a parachute, nice technology, and off they go. And these things, they barely work. They don't get used as intended. Nobody knows how to maintain them. We've seen in villages where the clinic had solar panels that only worked for a week 3 years ago and were never able to be maintained again. And the same thing happens in digital technologies. And finally, no sustainable innovation. You know at Google how important it is to have a culture of challenging your own assumptions and moving the ball forward and really seeing what is the next step, right? That innovation is part of your DNA. And what we saw, there was very little thinking about how to instantiate innovation processes in country. I mean, how are Cambodians going to invent the next technology that is necessary in Cambodia? So I'm going to tell you a little bit about how we tackled these challenges. The first set of collaboration gaps that we saw, we started tackling with the design of technologies. Over 30% of our users, people registered in systems using things actively every day, never access the internet. It's not like never as in once a week. They never access the internet. Actually, they might not even probably know that a lot of the systems they're using have cloud-based data centers behind them. They're just exchanging SMS messages with other people, sending data into databases, receiving alerts. And the whole notion of navigating to a web page to also see that information is probably not there. We have huge gaps with local languages. And we have some doodads here for you to look at afterwards. But Khmer, which is the language of Cambodia, is the closest language that exists today that is close to Sanskrit. You see some letters here. It's not benefited from any modernization in terms of the shape of the language, the characters, how a sentence are structured. There's multiple alphabets depending on what you want to say. And handsets that support this are not in high demand in the market. So there's a slow adoption of handsets that let you type an SMS in your own language. And finally, you think of a country with a lot of rural areas, a lot of villages with small clinics and health centers like these with no electricity, no connectivity. And who do you think requires the information the most to see what diseases need to be monitored for, and who has the best information about what is going on in the field? It's these people. In a systems metaphor, they are your first sensors, and they're your first and best and fastest actuators. So they're the ones who you really want to empower with all the information that you can, and you want to bring into these collaboration systems. Right now, the challenge is they take disease numbers in a piece of paper, it goes into a pile. That pile gets sent to the capital city every once in a while, or to the province, gets typed into a computer system, then it gets typed into another computer system, and 6 months afterwards, it gains visibility at the central level. Right? And a lot of the rapid response really happens through phone calls and people just trying to do an ad hoc process every time. The challenge with that is that the right people get missed, and the expert that could have contributed gets left off. Or as we found out, phone numbers change. Somebody in the field just wants to send something to the rapid response teams. They lost their address book number or the number changed. Suddenly they're out of the loop. And they have very little recourse but to get in a 4x4 later in the week and to drive and say the things personally. And these are all the challenges that our technologies are facing. So, and what we're doing to tackle it is designing technologies in the field. So the pictures we're showing is from visits that we do with our local team to discuss these requirements and these challenges in the local language, do some rapid prototyping, and implement some tools. GeoChat is one of these tools. It's evolved over the last 2 years. It's a mixture of groups plus messaging plus geolocation built all together. A lot of different components you could think of are from different tools you're familiar with. But the whole notion that somebody could send one text message and it goes to a group of people, and somebody else in that group replies, and it goes again to the whole group of people as a chat room, can be really revolutionary, as simple as it sounds, probably because it is as simple as it sounds. The notion that we can bake in geolocation from the get-go into almost everything means that analysis is simpler. And I'll tell you more about the tool later. What you're seeing here is a screenshot I took just this morning, 6 hours ago over in Bukdahan province in northern Thailand, jungle near the Lao border. We're sending some disease monitoring numbers, and I think these 246 and 5329 all relate to a number of sick people or people with a certain disease being exchanged. And by replacing the paper systems, going hierarchically with peer-to-peer based systems that share information in the cloud, we're making that data get to the people who need it in a faster way. Another one of our platform technologies is RIF, and the two technologies that helped the Haiti survivors were built on RIF. The 4636 shortcode you might have seen stuff about was sending messages that were authored in this environment where you could say, what are the messages that the population is sending in, categorize them, do the translation, do some analysis and slicing and dicing to see what are the trends from the field, what are people asking about, what are the issues that they're facing, and then author things in English, get them translated to Creole, and blast them out to geo-targeted groups. And this allowed us to send messages like these, that generic health messages. People started seeing that there were people complaining about eyes. So conjunctivitis messages started coming out, helping prevent a very rough disease. Hospitals were opening, and if you're short of trauma, pediatric, et cetera, hospitals, these sort of messages can be vital. We did an analysis with Thomson Reuters Foundation of what was the impact of the EIS system that we were in technical support of. It was really their initiative. We provided the geekery to them. Over 75% of people receiving these sort of messages changed their behavior based on them. So now, instead of thinking about cell phones as a way of reporting data and visualizing it while we're away, think about how we can use those two-way radios essentially to give the data that could help the crowds self-organize faster and better. And these messages went only to it went to under 30,000 people. If you think of over 2 million people affected, it's a drop of water. But it's a start of a trend. It's the largest scale system of this sort that has ever happened. And I think it's kind of become a milestone in the history of humanitarian technology about how to involve survivors and their mobile phones after a crisis. Boom, boom, boom. And as we go through working in the field and doing these designs, we find additional gaps. For example, you saw these little messages before with these numbers. Obviously, somebody's trying to report some data. Wouldn't it be good to be able to do the feature extraction and be able to analyze that and put that into databases for better analysis? So what we start doing is little cluster and collection of services that help with the bits and pieces. Locating somebody when they're sending a location name like Mukdahan or something like that is easy. When they're sending local village names in local misspellings, it's rougher. So obviously we have to wait to extract those place names from their messages. And we've built systems that combine machine learning algorithms and human feedback to basically allow users train the system how to parse information. So we went out there to the field and we tried doing some training to send in structured data to an SMS system. And we did a very simple exercise. We want you to report 5 cases of malaria and 3 cases of dengue. So we want you to send M5D3. Can you do that? Can you send an SMS with M5D3? Big letters on a slide, right? And it's very visible. Everybody send that. And we saw what came in. And analyzing what came in, people send everything from common misspellings, like missing the letter by 1, separators, new lines, expected things, all the way to somebody who just sent 5-3. And we asked, why did you just send 5-3? Didn't you see like M5D3? And they were like, yeah, but everybody else is sending the M and the D already, so why should I pay with my credits to send those 2 extra letters, right? If you try to surmount these issues, you'll have to train a whole country, right, in a whole countryside in how these things work. So you really have to make systems that adapt to their way of thinking. So scene tags is a pun on syntax, and it's one of the systems that we've built on top of GeoChat to allow people to report data, and it uses very simple user feedback to extract the data and the numbers, regardless of which order they come in, and uses some heuristics to do that. And all of this stuff is open source, and it can be used by anyone in their projects as well. Another huge gap, not just reporting numbers that we found, is a gap in literacy. I mean, you're dealing with semi-literate people, people who know how to read and write, but following certain sorts of instructions, authoring certain types of messages in mobile phones are beyond the capability of the training. And so we think that technology can help, and in this case, non-digital technology. What you're looking at here is a clinician in a rural area of Cambodia who has the task of reporting certain diseases every week to make sure that they go into the central analysis as fast as possible. And we really couldn't get them to send the syntaxes that were necessary to report this data. So we knew some sort of aid was needed. And our platform team, Nico Di Tada, working with the Innovation Lab team, which I'll talk about in a while, started putting together these non-electronic wheels, essentially, that allow somebody in their own local language to dial in the little cutouts to the left, what they need to report, and on the right they get some numbers, and then they just dial in into an IVR system, toot, 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 and in goes the data. The smart thing about this, it's not just that it's a physical device that they can hold in their hands that they can build on their own. We're creating a website where you can enter the data that you need to report, and it will give you PDF cut and assemble instructions that you can print and put together by yourself. The way that the data is encoded in the numbers to the right includes some error resiliency. You'll notice that they're all prime factors, basically of 2 primes. And based on the numbers that get reported in, we actually can tell whether they made a mistake sending the data, whether they should have been supposed to be reporting that data. And we can even guess with a high margin what was the data they were probably intending to send. So even if they miss a digit, it's not like there's a very small difference between reporting 1 case of malaria or 11 cases of malaria. Here, we can tell the difference, and it makes for much more accurate data from field, from locations that otherwise would not be able to report this sort of information this fast. And here's one of our early prototypes made out of paper. Of course, the final version has things in their local language, and because it's made out of paper, people just write other stuff on the disk for their own instructions, their own reminders, and so on, helping them be more productive and responding to a protocol better. And there's a whole bunch of building blocks. If you're interested in the architecture behind a lot of the InSTEDD services, we work a lot with national wireless operators. We have direct VPN connections to the people who operate the largest phone companies in Laos, Cambodia, Thailand. Sometimes we get asked how to manage their data centers and configure their phone systems in production, which is kind of scary in a way. But on top of their infrastructure, we have these messaging gateways, essentially multiplexers and demultiplexers that can work from a direct connection with a phone company all the way down to a little phone plugged in as a modem to a computer and bring all those messages into one soup and then route things to the different applications appropriately. GeoChat is one of such applications, and we have scene tags and other applications coming on top of that. Riff is the Haiti one, and it has other applications built on top of that. And what we're seeing now is an ecosystem of people building their own applications on top of ours to fulfill their own needs in health. This might not sound revolutionary to you. You're like, obviously, we make platforms. You make Wave, you put an API on top, you let people build their own stuff. It's a way of thinking, right? Let that innovation that is at the fringe of your effort be taken on by your users. But how many medical record systems do you know that you could just go and do a mashup around and get some data and add some functionality to? How many medical record systems do you think in low-income countries are built in a way that a very low-level developer with just some PHP skills can bring in and extend? And the answer is pretty much 0. So by actually allowing this sort of architecture, we enabled cases like these, where a local partner in Thailand, they needed to report real-time spikes in the reporting from hospitals of people with influenza-like symptoms, right? Before the diagnostics, just get the real-time spikes. And I've never even, actually I have to admit, I've never seen the application itself. But people who have seen it tell me it looks great. And what it's doing, it's taking real-time reports through GeoChat, right, off into this custom app that using the APIs, gets the data in, puts it in a database, does some very simple trend analysis, and comes back with alerts to the right geocoded facilities about disease alerts. And this sort of innovation, if brought into low-income country health systems, we think can be huge because there's a lot of local inventiveness, and also there's a lot of local passion to help improve your own society. But if you don't give them something to stand on, they just have to start from scratch, and it's just too hard, and this actually gets around that problem. Another example of emergent architecture was what was done in Haiti, where all these different building blocks now across organizations, including Samasource, Usahiti, Crowdflower, InSTEDD, Person Finder, Sahana, just kind of came together coordinated or real-time Skype chats with messages coming in from this phone company, going out through Nuntium, Riff, out through RSS feeds to Crowdflower, from there through RSS feeds to Use Haiti, and then analyzed by people, and people typing back things into Person Finder or Sahana as appropriate. Nobody had planned this architecture before, and it was great that it was put together. It helped. It saved lives. It helped things become better. I think the challenge now is to help systematize and plan this. When you're in a crisis, you have to really put on the blinders and say, what is the basic things I can depend on, right? So we have to transform this fantastic fluke into something that is predictable, something that is systematized, where the organizations can work together and all the response agencies that need it can rely on this in a way that's predictable. So I talked about the collaboration gaps. I want to talk a little bit about how do we design these systems. And I just talked about a couple of the applications we've built. I gave the metaphor of people coming to the United States from Cambodia with a mission to improve the health information system in 2 years, make it real time, web shared, etc. I challenged somebody doing that for Obama, but never mind. And they come with their own ideas of what might work, what might not work, their own cultures. So does anybody who's working over there. So if Marco Polo, when he was in his travels, he came to Africa with his own concept about what was out there in the world. And European lore had lots of stories about, dragons and fantastic animals. And when he went to the field, he found differences between all these things he had heard about and what was in reality. So if I told you now, put yourself in Marco Polo's shoes, and I say, imagine an animal with one horn who roams the plains, right? Who is huge and kind of magical in a way. Nobody ever sees him too up close. And this guy starts thinking, oh, wow, it's these unicorns, sound like fantastic. I got to go see them myself. And then sees this, right? That tells you how your own lenses, what you walk with as your own mindset can actually change what you expect to see. Now, when you're going in to design health information systems for low-income countries, you cannot afford to get the design wrong. And there are many things you can do to get around it. But the first one is really a very Zen attitude of don't expect. If you're expecting, you're already one step behind the game. And so we use methods to actually get ahead and across those barriers. The first thing is using Agile very aggressively. We're a small team. We only have 4 developers in our platform team and 4 developers in our iLab team, and they all use Agile practices. You probably do here at Google as well. Our platform team uses 6-week releases with 2-week iterations, XP Scrum sort of stuff. And our iLab team uses Kanban, doing more real-time prioritization of tasks. And this allows us to have a constant dialogue with our users, going back every 2 weeks and saying, is this right? Is this right? Is this right? Is this better? A or B, right? And keep evolving the system faster, because we don't know, our users don't know, the context is changing, and to discover what works, you need that dialogue and that constant discovery approach. We also use design techniques that allow us to experiment with systems even before they get built. This is a picture of Chane, our product manager in Cambodia. She is in charge of making sure that we understand our user requirements, doing the interaction design, rapid prototyping, and field support. And what you're seeing here is a live exercise of something called Wizard of Oz. And somebody had to explain Wizard of Oz to me because I haven't seen the movie as a kid. But in the Wizard of Oz, at the end of the whole journey to meet the wizard, they are in this big room and there's this big magical being appears and they start interacting with him. And it turns out that it's just a guy pulling strings behind the curtain, right? Don't pay attention to the man behind the curtain. What we do sometimes to discover what applications are needed before we ever get the chance to write one line of code, we do the same thing. We tell people in a clinic, hey, you know what? We have this fantastic new system. This fantastic new system will, if you send this text message, send you back what are the priority procedures you have to remind your staff of to be able to detect and constrain that disease in an earlier way? And they're like, oh, that sounds like a fantastic system. Can I try it? Oh, absolutely. Send this text message to this number, and you'll see the response. Or call this number, and you will interact with our specially trained operator who will be able to tell you the information. And the operator is somebody standing outside the clinic. The system is somebody sitting in the back of the room like you are, pretending to be the system and replying with the data. And so we get the real feedback, right? It's like, so what did you think? Is that response useful? Well, no, actually, I need more information about pediatrics because we work with a lot of schools here. Okay, let's do this again. Try it again. System, more pediatrics, right? And now the message comes back with more information around that. And in that way, pretty much in an afternoon, you can go through a whole gamut of potential applications you could do. You could kill fast the ones that are not applicable and get to a better understanding of those which are. And the thing is getting to what's appropriate for every level. We realize that in different contexts, different things are needed. What you're seeing here is a live, touch screen kind of interaction with avian influenza tracking data from Strong Agile back in 2006 or something, when these large stable touchscreens were starting to become familiar. And you see some VHF radios, the local cell phones, and we don't come in with a presumed idea of what works. We've chosen cell phones for some of our tools because it is what's appropriate for them. Sometimes it's SMS, sometimes it's voice. Now we're working to see if we can integrate for domestic stuff some of our efforts with more VHF and radio-based technology because that's appropriate for the local needs. So if you expect something to be the solution, the silver bullet, if you expect something to work in a certain way because it worked like that in other places, or if you expect the people to prefer one design over another one, you'll be surprised. So that's why we have to keep on our toes. And I think that the last but most important aspect, challenge that we found in the field, was a systematizing an innovation process, an innovation culture. How do you make people feel the ownership of the problem and give them the tools and the capital and the skills and the connections and everything else to go and tackle those problems? Really say, I'm going to take my stab at this. Again, in the US and in high-income places, you're used to the ability to that. You know that if you put your effort to it, you could get some data about your community, get some good visualizations and maps, and do something about your environment or your health process. That's why you probably work here. In low-income countries, that ball is still starting to roll. And our approach to bridge this gap was to set up what we call an innovation lab. 2 years ago, we created a local team where working in open spaces where other people from around the country and the region can come and collaborate. They are working every day on distilling what are these issues in the field, what are the simple technologies that can be built, and gaining skills in interaction design, development, quality, deployment, and support to make these technologies run. The pictures here are coming kind of rough. It's a low contrast thing. But what you don't see there is like an open space of one of our physical labs with a set of developers working, doing technologies and applications that were demanded by local people. They discussed the requirements in their own language. They coded them up. They deployed them. And they're doing the support and the maintenance and the evolution now. And imagine what could happen if you could have local developers understand the basic building blocks of these sort of systems that work in humanitarian scenarios. They know how to make SMS applications that work at the carrier grade, right? So they could build an application that sends 2 million messages per hour, just like that. They know how to make mapping applications. They know the basics of GIS. They know how to make applications that work with KML. They know how to do basic analytics. They are not afraid of learning new languages. And actually, we encourage that all the time, saying, try something new, expound your boundary, just get out of that comfort zone as a way of life. And it's gotten to the stage where I love coming to the lab every time I go, because they go like, oh, Ed, by the way, we made this application here. It's being used for this and this and that in animal health tracking or something. And FYI, there's like 200 people using it in such province. It's like, okay, awesome. And I know that it's all done by locals for locals, and that this is a sustainable long-term set of skills that exist in the country. there's another aspect to it. And what you're looking at here is a picture of a Bangladeshi woman who works for Grameen Shakti. Grameen Shakti is an energy company, social enterprise. They make solar products, high-efficiency clay ovens, and biogas sort of products. And what they do with their solar panel stuff is that they don't assemble the things in China, just bring them in and deploy them. They bring the crates of materials, the resistors, the boards, and everything, and they train women at the village level to assemble it. A woman can walk up to a Grameen Shakti office, walk up with a basket full of resistors and capacitors and some boards and get some training about soldering, assemble wherever she can get electricity some of these boards, and come back and sell each one that works at 8 cents a pop. In an average day, they can probably make around $1 a day assembling these boards. $1 a day puts you above the poverty line, right? And it also means that the women have skills to maintain and support and create their own support businesses around solar panels. Grameen trains schoolgirls to troubleshoot these solar panels, right? If a solar panel breaks, they don't have to call somebody in China or get a replacement. There's a local business. Somebody for a couple of dollars might help you fix your stuff. And this is a great example of how if you push a lot of your kind of like assembly to the edge, you're creating a set of skills that will allow others to innovate and create their own businesses and create their own opportunities and their own social enterprises with these newfound skills. And in a way, what we're doing at the iLab is similar with digital technology, right? I am sure that at one point in time, some of our iLab members will come up with this great startup idea and want to help society with technology in like their own organization and make a living out of that. And that to me would be a success, right? Because it means that we're getting the ball rolling in an ongoing way in the country. There's another form of innovation that happens that our innovation lab helps with, which is designing tools that are not just helpful in the problems that you know about up front, but also tools that will help with problems that you haven't yet seen. GeoChat, as simple as it sounds, with like it's just chat with some feature extractions and like alerts. I mean, what's a big deal? Well, to them, the big deal is that they're used to having all these special purpose vertical applications where somebody says, oh, you got to track malaria now. Here's a malaria application. You have to use a malaria database to tracking the malaria numbers and then send the malaria thing to the malaria report. And then they get this other application saying tuberculosis patients get tracked, name, age, sex here. Oh, wait, they have HIV. You have also to put them in this other database, name, age, sex there. It's a mishmash of technology. And one of the clinics we had, we say, like, how many patients do you see? Well, we see, like, I don't know, like 30, 40 every day except Fridays. Why is that? Oh, because it's Forms Friday. We just spend all Friday filling out the forms that our donors and our systems require, just typing things from paper into a computer. And we try to design our systems in a way that the users can define the use cases up front, right? GeoChat doesn't tell you should report malaria or you should report dengue. It's not like dengue chat, whatever. We let the users come up with that and design their own protocols and prioritize on their own. Unfortunately, that sounds logical and almost obvious to you, but it's not the way people have been exposed to technology in a lot of low-income countries. If somebody came and told you, oh, what you should use email for, well, sometimes I guess it could be helpful, but I know at least a couple of people who could use that. But there's a lot of local innovation. You just use the tool, you figure it out. And they're figuring it out on their own using these mobile applications. And here's an example of the translated slide that shows the sort of protocols that they invent on their own to report things. If I try to systematize this, do the H1N1 suspect case application, it would be a lot of effort. It would be special case. It would not withstand the winds of time. Probably after 2 months, it would be unused. And just by creating a platform with little add-on apps, we allow users to define these sort of things and then just use the tools and adapt the apps as necessary or not. They're just like see the messages they need in their conversations. Yet another way that we help the local innovation is supporting events that do the whole network, right? We talked about our partners such as Change Fusion that locally build systems for these 700 hospitals in Thailand. There's a whole network of organizations that are participating and wanting to participate in this. We've helped sponsor the first Barcamp in Cambodia, the first Barcamp in Myanmar, and we're doing the first Barcamp in Laos pretty soon. So if you want to come to Vientiane, you're welcome towards the end of the year. And you know what Barcamps are, right? As an open event that helps people bring together and share peer-to-peer series of skills and knowledge, you actually accelerate innovation. It's also great hiring grounds when we're looking for people. You know, whoever steps up to the plate to speaks at a Barcamp probably has some of the right materials to work with us. I want to mention Barcamp Yangon specifically because it was the largest one in the history of the planet. We only had 6 people from abroad there. We had facilitated the organization, but the organization was done by locals. And the night before, numbers of attendance had skyrocketed between like 300 to like 3,000 on the online registration tool. We actually thought it might be used for some sort of demonstration at one point in time, and we got quite worried. Myanmar is a very closed sort of country. The government is a really controls a lot of the communications. Bloggers were asked not to congregate for a Bloggers Association meeting, but we were able to do Barcamp by working with organizations that had a relationship with the government that were able to get the message through. That is, this is great for the local economy, like internal business exchange and things like that. And 3,000 attendees came through. The previous largest Barcamp was 1,000 attendees in in India. And 3,000 people showed up. A Barcamp of 3,000 people is massive, and it just speaks of what is the hunger for innovation and data sharing that exists in this area. These are just some of the organizers, to give you an idea. And you can't see them, but they're all very happy, and they're yay. Another example of user-led innovation is we had all these community village people exchanging messages about diseases peer-to-peer through GeoChat, as I explained before. When Ketsana came through, Ketsana was a large tropical storm that came through Manila, Vietnam, and Thailand, basically flooding the place, destroying houses, very high winds. It just started sweeping through a lot of villages, causing a lot of destruction and floods. And as an example of user innovation, they started using GeoChat as a way to do peer-to-peer support and messaging and alerting what was going on. Not in like there's a storm coming from, because they don't have access maybe to like the big sort of forecasts, but they were, with their local knowledge, able to send alerts such as, this river is flooding, right? No sensors looking at the river, trust me. This river is flooding, watch out, tell people to move away from it. Tell people not to stand downwind outside their houses because the house will collapse on them, and we're having a lot of injuries happen that way, or stuff that flows off the roof or from under the basement and just hits them. And this peer-to-peer support network was something that we didn't foresee. We knew that, you know, having people interconnected in a reliable way would help these sort of trust networks form, but actually seeing it in action was really transformative. And again, a voice that if you empower people with the right tools, they have plenty of need for these sort of communications. And finally, our innovation lab in Cambodia is a multidisciplinary team. We have program managers who are working with accounts and are working with government and with the NGOs that do like, you know, landmine picking up, and that they do, like tuberculosis management. And this is a picture of our library, and you might not read some. So I'm just going to tell you the sort of books that you'll find side by side. You have Ending Hunger, you have Smart Mobs, you have Directory of Cambodian NGOs, and you have the Pragmatic Programmers, right? Books. All of those in the same library. And that tells you kind of what sort of place the lab is. Like when you have Ending Hunger next to the Pragmatic Programmer, it tells you something about the sort of work that is going on and the sort of cross-disciplinary thinking that has to happen every day where people are challenging each other's ideas. We call ourselves a socio-technical team because we don't know how to describe it. We're not about technology, we're about applied use, and we're not just about sociology and the policy of disease surveillance. We're about changing the numbers and making an impact. So we haven't found a better way to describe it than that. So essentially, this is some of our work. This is a little bit about how we work and what we do. And I invite you to help us in ways that you think are appropriate. And want to help, what you don't see very well is this is a picture of some Buddhist monks who wanted to help us. So they came to our innovation lab and they blessed the generator. They said, we know the generator is important to you for your work, so we will bless it because we want you to keep doing this sort of work. And that tells you, you can help from your strengths. I can tell you Google technologies are helping a lot in all the sort of work I've shown you before. Things like Google prediction APIs. Those things are awesome. They're saving us a lot of work as soon as we get the key approved. But basically, they're going to save us a lot of work that otherwise we would have to start cranking on our own or finding people in the universities who can like contribute that in an open source and cheaper way. Simple things like the Google widgets, you know, the little charts APIs. Those things can help my lab in Cambodia give great interactive applications with just, you know, some HTTP calls. And those kind of productivity boosts are really helpful. And of course, everything with Google Earth and the geospatial work that you're doing is also critical for this sort of work. And that's those sort of building blocks, like the prediction API, the widgets, really allow our teams to focus on the unique problems that are found at the edge. And I think it works great as a partnership. So if you want to learn more about like crisis response, we have some things here, examples of the equipment. For the benefit of the camera, this is one of the satellite vegan terminals. Whoops. They're kind of expensive. It's more expensive to send data through them. VHF radios, satellite phones. And we can talk about how you can work on hacking your own community and its safety processes locally, or if you want to learn more about international stuff later on, and how you can help from what you do in your team already. So finally, I wanted to thank Google.org for their support. It's been very hard work these last years in a very intense way, but it's been, I think, a great, very innovative initiative. And in the upcoming years, we're really excited about how to see these platforms that we've deployed and are being used by the thousands really snapping all those local innovation opportunities and all that creation that can happen in the other countries in a way that really hasn't happened in public health before, and in Africa and other areas as well as Southeast Asia. So here's my contact info, Twitter, etc. If you want to talk. And I think we have some time for questions, so if we can do that. Just one or two. That's great. Okay, so maybe one or two questions.
Sure. Obviously, fabulous work here. One number that stuck out in my head, though, you said 1 million SMS messages in Haiti. Tell me about billing and what makes all this stuff go, because, you know, people and the one guy who's trying to shave a couple characters off his message.
Well, billing, the way it works really is about partnerships with the private sector. It's about partnership with the phone companies. In Haiti, obviously the phone companies knew that they were going to be part of the critical national infrastructure. They were working 24/7. They had lost staff. They had lost facilities and antennas. And they were really working nonstop to get that cell system up. We were talking with the CEOs and the owners and the product managers of Digicel and Voila, who are the largest organizations, getting direct VPN connections into their data centers, talking SMPP directly into their servers, working with their team every day. They would be like, we have to turn the server off because we have to move the data center because we have a problem with the generator and da-da-da-da-da. Okay, we're off for 1 hour starting now. Okay, up now. Real-time collaboration across countries. And that sort of collaboration at the technical level and at the commercial level is critical. In Cambodia, we have a shortcode that is available nationally for GeoChat users that is free to send and free for users to send things in and free for alerts to go out. Now, I tell you, there's a free shortcode you can use to build any sort of social application in Cambodia right now. In Laos, pretty soon. Actually, it's working, but we haven't announced it. In Thailand, it's working. And in Vietnam, pretty soon. And China. But China is interesting. So
that's the national government is supporting.
It's a mixture of the national government and the phone companies, really. Sometimes coming in through the GSMA, sometimes coming in through connections to the owners, or through the parent companies. Ministries of health do not have much power in low-income countries. Phone companies are more powerful. So you have to know how to talk to them. And actually, we have a mix of experiences in InSTEDD, including working in the private sector for many years. So we can get to a negotiating table and talk, how can you help support, Cambodia health and, support your business at the same time? That's a sort of win-win we can help design. And we've done it. Yeah. Any other questions? All right. Thank you.